what is Mesos? Basically, on its own, Mesos is this. So it consists of, on one side, Mesos masters. So these are servers, instances. Mesos masters that actually just make sure that manage the whole bunch. And on the other hand, you normally have a much bigger pool of other servers, which are called Mesos slaves, and they renamed that now to Mesos agents. So this is really where the work has been done, like where your applications are running, your workloads are running. And underneath there's Zookeeper to keep state of this whole thing. Now, on its own, Mesos is not that much. It's a resource manager, so it will constantly talk to the slaves and ask, okay, do you have memory free? Do you have CPU free? Do you have network free? So it can allocate CPU, memory, network, and disk space for applications that want to run on there. But let's say I want to run a long-running service like a web server. If it goes down somewhere, well, Mesos is happy because it gets resources back, but I'm not happy because my web server is down. So again, Mesos is quite simple in just managing these resources. So there must be something more to really be able to orchestrate applications, databases, workers, all sorts of stuff. And they offer that in the form of frameworks. Frameworks are basically pieces of software that sit in between the applications and Mesos itself, and will constantly talk to the Mesos master asking, okay, I have a new application here, where do you have resources available for me? And shoot them into that server, or launch it on a couple of servers. If I say, okay, I want my web server to run in at least 10 containers somewhere in the pool of instances, then you can instruct or the framework can instruct Mesos, the Mesos master, to do that. Those frameworks usually also talk to Zookeeper just to keep it nice and simple and not having too much of those things that keep state. And the two most important, or the two frameworks that are basically packaged or managed by the Mesos community are Marathon and Chronos. And Marathon is a framework that you can see basically as a systemd or an upstart for the data center. So when you say, okay, I want to run an application, I want to make sure that it always runs regularly, use something like systemd on a Linux machine to keep it up and running. When it goes down, it will pick it back up. Well, basically, Marathon does the exact same thing, but for a bigger pool of servers. We'll see, okay, this application needs to run somewhere, and we'll constantly ask Mesos, is it still running? Is it still running? And we'll instruct it to run it if it's not. Chronos is the second one, is quite simply a cron for the data center. Same thing, like I want to run a certain workload, a certain task, a certain script, doesn't matter, somewhere in my pool of servers, don't care where, just when. Then you can use Chronos as a framework and send your jobs in Chronos, say, okay, they need to run every day, every hour, every minute, whatever. It works like a cron, but for the data center. But then outside of the pure community, there's also, well, they also come from the community, obviously, but they're less attached to Mesos. There's a bunch, and I listed 5 well-known ones, but there's so many more services that have written their own frameworks for Mesos. So Jenkins, if you have a huge workload of Jenkins jobs, you can just install it on Mesos, so all your jobs get nicely spread out. Kafka, Spark, Elasticsearch, the whole Hadoop ecosystem can be installed on Mesos, and it's quite tight to it, by the way. But so many more. So voila, that's the view on Mesos plus its frameworks. And basically what I initially wanted to show today, because I've been running Mesos in production for almost 2 years now, was the way we installed it in our company with Ansible scripts on many servers and bringing everything up. It works really well. We've been running it for 2 years. It's one of the best choices we've made. But 2 weeks ago, the community, the Mesosphere is the company behind Mesos, or at least the support company behind it. But they open sourced a thing called DCOS, and I kind of had to scramble and see, okay, what do I do now? But I had a look at it, and it's really, I mean, yeah, it was a bit new to me. Although, yeah, it's just packaging all of these tools, Mesos, Marathon, Chronos, in one nice bag that's easy to install, easy to maintain. But yeah, so I kind of a risk to say, okay, no, let me try this. Let me try this for the presentation. But it's a really nice tool. So DCOS, the whole management maintenance system to have Mesos running with Marathon and all the other frameworks that you want is now DCOS. Stands for Data Center Operating System, and you'll see when I give a demo, all the terminology they use is like operating system kind of terminology, but they branched it out to a whole data center. So you manage it from one side, but actually your jobs get spread out over your data center. So it's the glue between everything, basically. They offer a UI on one side, but also a CLI in which you can do basically the same things, depending on your needs, on your wishes. And then here, kind of a marketing thing that probably explains it better than I do. But so in the whole system, there's 3 layers. So your base layer is your bare metal, your instances, your AWS instances, your Google Cloud instances, Azure servers instances, I don't know how they call it. So it doesn't even matter where you run things, bare metal on premise, on my laptop here, doesn't matter. That's your hardware layer, basically. Then in between, there's Mesos, which I already said is managing the resources in this whole pool of hardware. And then on top, there's your applications that get to run through frameworks. So voila, that's the talk. Now, actions speak louder than words, obviously. So I'm going to give a demo. Let me close this up. So, it's going to be better. So maybe it's a bit small, but it doesn't matter that much. So yeah, I'm an avid AWS user, so I'm going to show everything. Well, I'm not going to show much in AWS, but we're going to run this demo today in AWS. They also have out-of-the-box scripts ready for Azure and Google Cloud, if I remember well. You can run it in Vagrant if you have enough memory on your local machine. And then just on bare metal, but it requires a little bit more scripting and configuration to get it up and running. But for instance, for AWS, it's just as simple as launching a CloudFormation template, which is basically a file, a JSON file, in which you define, okay, I need this many instances, I need this network resources, I need these disks. Like it's just a shopping list basically of all the resources you're gonna need in your full infrastructure. So this is a list. On the left there's the zones, the regions, sorry, that AWS. So for today, well, I already launched it, but it's just as simple as clicking launch stack. So in Frankfurt, for instance, launch stack. Bump it up a little. Nothing to change here. Here, I give my stack a name. I define, okay, what IPs can have access to the admin part of this whole infrastructure. I decide on a SSH key I want to use to log into my systems. OAuth, you'll see later. And then here I can define, okay, how many public slaves do I want and how many normal slaves or private slaves do I want. Usually public slaves are for things open to the public, web servers, things like that. And the other slaves, which are more tied off from the world, is for databases and very sensitive things that you don't want to open up to the world. So you can just name a number here, 3, 10, 300, whatever, say for both types. And also later on, if you see, okay, my workload is growing, I'm not cutting it anymore. You can just adjust it by changing that number, and your infrastructure will scale out horizontally. So if I go through, it will launch the whole bunch, but I already did that. So I'm going to close this up. I'm going to go here. So I have one that I used for yesterday, DCOS demo. So just a quick look. These are all the resources I defined, well, or at least DCOS defined for us that you're going to need. And it took about 10 minutes, I guess, to launch this whole thing. And my whole infrastructure is running. It gives us a couple of outputs in which there is one URI to the Mesos master, and I think I already have it open here. Okay, so this is the login to our whole DCOS UI, admin UI. OAuth, I could enable that, disable that. We're good developers, so we're going to use GitHub as a login structure. Give it some time. Yeah, I can't change the contrast on this thing. Is this visible enough? So this is a fresh new well, DCOS infrastructure. And as you can see, this is the overview, kind of like when you open the activity monitor on your machine. It shows you the CPU, allocation, memory, things like that, all the things that are running. So it's just a nice overview. Well, it's quite empty right now because it's a fresh new server, a fresh new infrastructure. Here we'll say, okay, these are all the operating system services that are running. The nodes that are sitting underneath, so there's 4 here. In this cluster, I said 2 public ones, 2 normal private ones. So they're listed over there, all doing nothing right now, obviously, so all 0 values. Universe is kind of the apt-get, so you will, for the data center. So here you can see all those things I listed earlier, all the frameworks that you can install just by the click of a button on your infrastructure. There's the ones they support natively, and then there's all sorts of community packages, community frameworks, HDFS, Redis, Nginx, OpenVPN, and the list goes on and on and on. Docker Swarm, because in the end, Mesos is just a resource manager, so Docker Swarm, which we'll see later, can just run as well as an orchestrator on top of Mesos. So you can also install it in DCOS. Kind of meta, but it's possible and it works quite well, to be honest. And then there's some system stuff. To be honest, I don't really know what all of these things are, but they all look green, so that's fine. Right over here, very small, but there's a install CLI screen that just gives you a command to install the CLI, so that from my terminal I can do all the same commands that I would do in a UI. But today, to keep it more visual, I will stick to the UI. That looks a bit nicer. Okay, so let's get on with it. I'm gonna take my playbook here. Okay, so we're gonna launch our very first application. So I go to services because I'm gonna launch it in Marathon. It's a long-running service. Okay. Open service. So this will open the Marathon UI. So now we're in the Marathon framework UI, which is also empty, obviously, because it's new. I'm gonna create an application. Sorry, a very complicated one. So I give it a name first, app. Then I have to define what resources my app will need. For memory, that's quite easy to understand. Like it's a very simple thing. So I only need 32 megabytes of memory. I don't care about disk space. I'm not writing anything to disk, or I don't have any dependency on disk. I'll just run one instance for now. CPU is a little bit harder to understand because you just cannot cut off a piece of a CPU, but this kind of defines a priority. And it's my experience that it's in the beginning a bit hard to understand, but basically the more workload you get, you match up with the actual CPU usage, and you change the numbers accordingly. It would be cool if they could ever provide kind of a tool for that to match that a bit, but as I said, the CPU cannot really be cut off, so try to understand it as a priority you give it. So apps with a higher CPU resource allocation will get priority on the CPU too. I'm gonna set it really low to 0.1. And it's a Docker meetup today, but actually, and that's I guess different from Kubernetes and especially Swarm. It's not necessary to run Docker containers through Marathon. You can just run whatever command you want to run. So in this case, as a start, I'm having just a very simple while loop here that sleeps for 10 seconds and then prints the date. So that's it. There's other options here. We'll get into those right away. But this is, I think, one of the most simple apps you can write. So I'm going to create this application. It's deploying, as you can see here, and it's already running. So my application is running over here, somewhere in, somewhere on an instance. I don't care where, to be honest. But I mean, if I would, I could see here the IP, but it doesn't matter. It's running. I'm fine. And to see what exactly it's doing, let me get back to the Mesos UI. So the Mesos UI will list, okay, Marathon has asked me for some CPU and memory, and it's running this application. So if I click that application, I have a couple of administrative things I could do. I can see the files this application is creating. std out and std error is default, but could be others if I were to write two files. Some details about it, not too interesting. But here is the std out and std error of my applications, which is quite nice because when I'm actually running a cool application, and usually it's just in one thing that it goes wrong and all the others work fine. So this gives you the opportunity to trickle down that one and say, okay, what is it outputting right now? So as you can see, it was a while loop that printed the date, and that's what it's actually doing over here. Now, okay, my application, super cool. I'm getting a lot of buzz about this, so I need to scale it up. So what I could just easily do is go in the UI, the big blue button. So now I have only one instance running. I could go up to 2 or 3, whatever, doesn't matter. I'll stick to 2. Scale application, and it will provision somewhere again in the infrastructure a new application. 2 applications are running of this, or 2 instances of this application are running somewhere in the stack. You see the same thing here, blah blah blah. Okay, I think it's fine. Okay. My application is nice, but I think it's too slow, so I want to change it. I can go in its configuration and say edit, and 10 seconds is too long for me. I want it to output the date in 5 seconds. I deploy it, and but I'm not going to be quick enough. What actually is going to happen is it's going to launch 2 new applications of the new version with the 5 seconds. Do a health check if I define the health check, which I didn't. If they're healthy, then it will kick out the old 2. That's kind of how it works. We'll see that probably later with Docker containers that need some time to load. Okay, super simple. On to the next. Okay. So now I'm gonna do something a little bit more exciting. So let me open my editor here. And ooh. Wait, I'm gonna do it a little bit different because this is just unreadable to me. So now I want a simple HTTP server to be launched. So I could configure it again in that nice UI, but we're good ops people, so we configure everything, we keep everything in version control. So I define it in a JSON file. Same kind of options we had earlier, IDs, CPU, memory, disk allocation, so on and so forth. I can define here, launch it only on public nodes. So I said, I say, okay, only lock it to this role. It's every server in the system has a role. So this is the one with, or I say my job to launch only on the ones with a public role. I can also set constraint, which is a more granular definition. I'm saying, okay, let's say we have 10 servers in our pool and have an application that I want to run on all 10 of them. I can say, okay, launch 10 instances of this application, but make sure that, and then add a constraint, hostname is unique, meaning that it's only one per server. So it needs to run on all of them. So hostname unique defines, okay, it will run, or it will not launch a second application on the same server. That's basically what it's saying. So for instance, for log shipping kind of applications, this is very, comes in very handy. And there's many other sorts of, you can bin tag application all on one server. I mean, there's many kind of constraints you can set. Then information about the container I want to run. So I'm going to run a Python container with a bridge network that the container itself provides service on port 8000. But I want to know, or I want service to be known on port 10101. This is kind of, it's not used internally, but it's kind of a unique ID that you give to the application. So all the same instances of that application will be known by this service port, basically. But then, and this is kind of new, for load balancing, there's also now a system in DCOS called virtual IP addresses, which basically bind all the same instances of one application under one IP address plus port binding. So here I chose IP 1.234 on port 5000. So when within my system I go to that IP, under the covers in the kernel of the DCOS, it will get load balanced to one of the instances I need. So this is very low level service discovery, but very powerful because you don't have to install any console or use Soupeep or use whatever. You just provide it as you go. You don't have to install anything. It's there and it works really well. This is new. I'm very excited about this feature. Super cool. Then I could add some extra information here, like health checks. So it's a web application. I'm going to check the root path with some intervals and grace periods and stuff like that. And voila, that's my full application. So I'm going to copy paste this whole configuration. I go to the main application list, want to create a new application. So I could define it here, but there's also a switch here that lets you just insert this whole JSON file or JSON output, create application. So it is deploying, and now we see, okay, Marathon has talked to Mesos, and it will allocate resources, and Mesos has said, well, here are the servers you can launch it on. And voila, so it's done. So they were staging, meaning they were pulling in the image, starting things up, and when everything was ready, and health checked if, because it's still deploying, meaning the containers are already running, but now the whole health check system is doing its thing. I think it needs 2 or 3 consecutive, consecutive healthy feedback, and then it will say, okay, the application is entirely healthy, so the deployment is done. Okay, so what I'm going to show now, I'm going to open this up. Readable? So here I'm logged in to the Mesos master. So the IP of that one is somewhere over here. So I logged into this IP. So logged into the Mesos master, and from here oh, sorry. From here, I can do a curl to 1.2.3.4 on port 5000. So this is that virtual IP. And I get HTML back. This is the web page I get back. Don't know, don't care what instance it exactly came from, but under the covers, it was load balanced to here. So if I repeat it again, can come from another one, I don't know, but it works. So this is really cool. Again, I like this very much, but a second kind of service discovery that's built in is, I think also what console kind of provides is DNS records, and specifically the DNS serve SRV records. They're also installed and provided out of the box. So if I do a name lookup and allow me to just copy paste this, do this, I get information back saying, okay, there's 2 instances of that running on these ports and on these instances, which are then further defined over here. So on the 5.3 and 5.2, they're running on this port. So should you have applications or tooling that uses these kind of things? There is also A records, but they just point you to the server where it's running. You don't really know. Because, yeah, that's another thing I forgot to mention. Marathon, just by default, unless you configure it differently, just chooses a random port. So my application internally was serving on 8000, but the Docker bridge network is attached to just a random port that's free somewhere in the system. So on one server it's 16,000 something and 22,000 something on the other one. So that's why this whole service discovery is quite kind of important, because ports are just assigned randomly. So just finding your services just like that is not easy. So you need tools like this. And that's why there's A records also that will tell you, okay, you can find the system there, but it doesn't really tell you anything. It just tells you on those servers, but beats me where the ports are. So that's why you need the SRV record. All right. Now I want to make that because the IP, the 1.234 is that's internal, but from here, from my laptop here, I cannot reach that obviously. So I need a system to make things public. There's numerous ways of doing this, but one is just HA proxy. So I can install in Marathon an HA proxy application in which I define an HA proxy container and an HA proxy container with a certain configuration in which I just map an incoming port to that VIP. And for this application, the rest is for later. But for our application here, the simple HTTP server, I tell it to listen 8000 and then send it through 1.34 5000. So let's launch this thing too. Here. Yeah. Oh no. Too many blue buttons. Create application. Same thing. Go in JSON mode. Copy paste. The configuration is somewhere on GitHub gist. It's very simple. Creating an application. It's deploying. Started on 1. So now it's pulling in the images, so sometimes it can take a while. And deployment is done. I've forgotten health check here, so for Marathon this is done. Like there's no health check, so deployment done. Then, if all is well, so what I said here is launch HA proxy on every public node, and there is a DNS where all my public nodes, because they're in an auto-scaling group, all my public nodes automatically are added to, and that's the one underneath. Okay. So that's bad news. I'll just go directly to one. Sorry. No, I know, sorry. Out of the box, I don't know why, but the load balancing configuration in the CloudFormation stack, so the thing we launched at the very beginning, is, in my opinion, super weird because they do a health check that doesn't exist. So, check proxy. So basically, this load balancer that sits in front of all my public nodes isn't doing anything because it says everything is out of service behind it. So I think this is correct. If we look at the instances, okay, now the nodes are in service and hopefully, okay, still not cool, not cool. That's the thing with live demos. So this is when I go to one instance directly. This is my application that's served through the HA proxy application, and then from there is dispatched to the 1345000. Yeah, not sure what's wrong here. Yeah, obviously, I was working too much. I also have to define the listeners, of course. So I said it was port 8000. 8000. Save, close. And now, okay, well, we're there. That's what you get when you prepare just a couple of hours before. Yeah. Let's discuss that afterwards because that's a topic which I can spend an hour on. But it's, I mean, Marathon Load Balancer is another application you can put in front. My opinion is that it's a bit too heavy for what it's just supposed to be doing. And Marathon Load Balancer was also built before they introduced these VIP virtual IP addresses. So in my opinion, it complicates things that shouldn't be too complicated. And that's why I didn't cover it today. But yeah, I mean, I've experience with that if you want more information about that afterwards. But so forget about that for now. Okay, now, okay, so that's 50 minutes, nice. Okay, so this was this simple application. And now onto the thing I presented at the very beginning, the Docker birthday app with those 5 applications. So we'll start with one of the databases, the Redis. Yeah, I mean, we're starting to get the hang of this. I guess we give a name to this application or a unique ID, some provisioning of CPU, memory, and disk. Also on public, I don't think it's necessary because I was debugging and I thought this might fix things. Maybe it fixed things, maybe it was something else. A Redis image that listens or that opens in the container its default Redis port 6379. And I create a virtual IP on 1234 and then the same kind of port. The reason being is the applications were already pre-built and out of the box they use this port, so I didn't touch it. Docker. Another topic of which I can spend probably several hours on is volumes, because you can define volumes and say, okay, I pre-allocate a volume on one instance, or Mesos can do that for you, making sure that, let's say, the instance dies, that it always gets back to that instance and picks up its already existing volume. So for databases, that's obviously kind of important. When a database process dies, that you don't lose the data. So that's also now entirely and nicely out of the box in DCOS. Volume provisioning, making sure that instances find their volumes back when they need to. So really cool feature also. And here, because it's a stack of applications, I'm gonna give them some extra labels. So in this, I say it's a type DB. So when I get a bunch of like hundreds of applications, I can pinpoint the ones that are DBs, apps, and so on and so forth. Again, I didn't bother to add a health check. Shame on me. Okay, gonna launch Redis in Marathon. Create application, JSON mode. By the way, so now I paste this in JSON. When I turn this off, this nice UI is entirely pre-filled and I can still fumble around. So what Docker container, the ports and the VIP environment variables, should I have them, labels, as I said, DB, health checks, volumes. So container volumes, persistent volumes, that's the thing I talked about. Some optional stuff, slave public, so on and so forth. So it's easy to switch back and forth between. So it's actually easy to configure it a bit in the UI and then just go to the JSON mode, copy paste everything and dump everything in GitHub. Create application is deploying, pulling in. I just launched one instance because Redis with masters and slaves is a bit more difficult to set up. So. Is deploying again. We'll already go on to the next one, and that's the voting app. So the marketing team already asked us to set up the voting app, didn't care about the result page yet, so we can just do that. It only needs the Redis. So the voting app is over here. And again, same thing, some extra information here. For one reason, because I was tired of debugging, I guess, but I switched to 111 as an IP space for the virtual IPs, port 5000. I already defined this in the HA proxy we launched earlier to point port, I think, 8080 to this one, 115,000. And one very important thing, so in Docker containers, you can ingest things in your etc hosts file by on the command line saying add hosts and then the host you want to add. So I'm doing just that. So I'm running against the Docker command that Mesos will run for us, the -- add host flag, and I say, okay, Redis can be found on 1, 2, 3, 4. And yeah, because we take the default port, I cannot define a port here because it's just a name to IP mapping. But yeah, our driver is smart enough to just use the default port. Reason being, and that's the nice thing of this, so in the Docker Compose file, you just say, okay, I link to the container with the name Redis. But yeah, we don't have a kind of a Docker Compose knowledge in Marathon. But I can just reuse this whole ID. So my application says, okay, connect dot to whatever Redis, and I just wire it into the etc host file. So if my application goes to Redis, it will go to 1, 2, 3, 4. It's really, again, this is the service discovery I was talking about. It's nicely out of the box. Your application can just stay as they were. No need to change anything. You just wire the things underneath as they go. I label this as an app. It's not a DB, obviously. You all knew that. And applications, getting a bit boring now. JSON mode, create application, deploying. Start on one, started on the other. Who's going to start? In the meanwhile, not going to make the same mistake again. So adding another route on our load balancer in front of all the public nodes that listens to port 8080. Yep, sends it to port 8080. Oh. Save that. Close it up. If all is well, everything is launched. And hopla. This is our voting app. You can choose between Python and JavaScript. I'm obviously a hipster, so I choose JavaScript. This goes now in the Redis queue. It's sitting there. There's nothing working on it just yet. so that's fine. Okay. Okay, cool. So marketing team happy. They can send this out to the world. Now back to the trenches and the whole processing of this thing. So a worker underneath Java application. Well, I'm not going to do it again. Just this one is connecting to Redis and the DB Postgres, so also to the default ports, which I cannot define. Oh, by the way, first Postgres, obviously, or the app won't be happy. Okay. Marathon applications, create application. JSON mode, yep, Postgres, okay, and then that was Postgres. This is my worker. Okay, creating another application. Voila. 2 instances of this, 2 workers. We expect a lot of people, so we're nicely distributed and working in parallel on things. And now, just to see if everything is going well, what I'm gonna do is go to the worker, and I think. Oh. Log viewer. Yeah, so this application or this instance of the application is connected to Redis and watching the queue. So this one hasn't done the work, I assume. So probably the other one. I don't know which one I clicked. Basically, yeah. Maybe it's reshuffling them. Voila. So this is the one that picked up my vote, got it from the queue, and stored it in Python. So that part is working. It's getting in a DB now. Final stage, the result app, which is over here. So result app, same thing. It's an Node.js app with a little hack here over here. So I wire in a port variable because by default, Node application or a best practice, call it what you will, have the port as an environment variable into the system. But Marathon already writes the port it assigns, the one it picks randomly, and adds it as a environment variable in your container by default. So I need to override this because I want my container to serve on port 80. So it's kind of a little hack you need to do just for this type of applications. Okay, final one. Create application. Create application. So it's launching, and I think I set this on port 81. 81. Save. Okay. Okay, voila, that's my resulting app. So I was the only one to vote for JavaScript, so obviously 100%. I don't know how it's gonna work when I change now Python. So it's getting processed probably, and voila, it changed. So end to end, everything is working with 1 minute to spare. Thank you.